Imagine staring into the night sky, expecting to see just another speck of light, a comet, ancient and predictable, drifting through the void. That's what we thought 3I Atlas was, a relic from the solar system's birth, a frozen fossil trailing dust and gas. But what if I told you this object is rewriting everything we know about comets? That it's not just a rock, but something pulsing, shifting, alive in ways we can't fully explain? Hold on, because this story is about to take you to the edge of the cosmos and leave you questioning what's really out there. It started in late July 2025, when astronomers first noticed something odd. Comets glow when sunlight heats their icy surfaces, releasing gas that catches the light. But 3I Atlas? It shouldn't have glowed at all. Its surface, speckled with reddish hues, lacked the key ingredient diatomic carbon, or C2, which fluoresces at exactly 518 nanometers to create that iconic green halo. Yet, there it was, a faint emerald shimmer, barely visible at first, wrapping the comet's coma like a ghostly veil. Why was it glowing? What was powering this impossible light show? The answers, it turns out, only deepen the mystery. By mid-August, the coma, the cloud of gas and dust around the comet, didn't just grow. It surged. Picture a balloon inflating in erratic bursts, swelling unevenly until it stretched to nearly half the sun's diameter. This wasn't a gentle expansion, it was violent, unpredictable, like something breaking free. Astronomers scrambled to understand it, pointing their telescopes and spectrometers at this cosmic enigma. What they found wasn't just surprising, it was unnatural. Using polarimetry, a technique that measures how light scatters through space dust, researchers uncovered something extraordinary. The light from 3I Atlas wasn't scattering randomly, as it should in a typical comet's dusty cloud. It was organized, structured, almost deliberate. Bands of charge, zones of shifting polarity, and rings of magnetic order formed within the coma. This wasn't a chaotic cloud, it was a system, with a calm, perfectly symmetrical core at its center, silent and still, like the eye of a storm. How could a comet, a mere ball of ice and rock, produce patterns this complex? Was it reacting to sunlight, or was it responding to something else entirely? Let's pause here. Comets follow rules. Their polarization, the way light aligns as it scatters, follows a predictable curve, negative at low solar phase angles, positive at higher ones. It's a cosmic fingerprint we've mapped for decades. But 3I Atlas breaks every rule. In August, at a solar phase angle of just 7 degrees, the angle between the Sun, the comet, and Earth, it showed a polarization of -2.9%. That's extreme, far beyond what even the massive comet Hale-Bopp showed in 1997, which dipped to -2%. And the inflection point, where polarization flips from negative to positive, usually happens around 20 degrees. For 3I Atlas, it flipped at 16.8 degrees, too early, too abrupt. The entire curve is skewed, lower at low angles, higher at high ones, like it's dancing to a rhythm we don't understand. So what's going on? Here's where it gets wilder. The polarization curve of 3I Atlas matches something unexpected, trans-Neptunian objects, or TNOs. These are frozen worlds orbiting far beyond Neptune, relics of the solar system's outer edges. Their polarization curves, though incomplete due to their distance, look eerily similar to 3I Atlas. Could this comet be a fragment of one of these distant bodies? A shard of a world we've barely begun to explore? Its reddish surface and structured coma seem to support this idea, but there's a catch: TNOs don't glow like this. They don't evolve in real time. And they certainly don't accelerate toward the Sun at 68 kilometers per second, as 3I Atlas is doing, hurtling toward its closest approach on October 29, 2025. Then came the night that changed everything, September 7, 2025, during a lunar eclipse in the Atacama Desert. Under the copper-red glow of Earth's shadowed moon, astronomers trained their instruments on 3I Atlas. What they saw defied logic. The green halo wasn't just brighter, it was vivid, sharp, structured. Not a diffuse cloud, but a corona with layers, edges, and zones of brightness, like a cosmic sculpture carved by invisible forces. Spectroscopic data confirmed the presence of diatomic carbon, but earlier readings from July and August showed levels too low to produce this fluorescence. So what changed? Why was the glow so intense, so organized? One theory suggests 3I Atlas is shedding a hidden layer, like a snake sloughing its skin. Deep beneath its crust, exotic materials, frozen CO2, hydrocarbons, maybe even nitrides, could be thawing under solar heat, releasing and ionizing in the vacuum of space. But this doesn't explain the structure of the glow, which looks less like random gas and more like a plasma field, charged and reacting to the solar wind in ways we've never seen. Some scientists whisper a bolder idea. What if this isn't fluorescence at all, but plasma excitation? A field generating its own light, not just reflecting it. This echoes another strange visitor, Borisov, the first interstellar comet spotted in 2019. Borisov had its quirks: unexpected CO2, odd polarization, but it never glowed like this. 3I Atlas feels different. More dynamic. More unstable. More intentional. Let's step back and consider what this means. This object, speeding toward us at breakneck speed, might not be a comet at all. It could be a fragment of a distant world, a relic from a collision in the outer reaches of our solar system. Or it could be something entirely new, a class of object we haven't named yet, one that adapts, evolves, and responds in ways we can't predict. Its coma isn't just gas and dust, it's a living system, shifting with every angle of light, every pulse of solar wind. And that green glow? It might not be a random effect. It could be a signal, a beacon, a marker of something we're not ready to understand. As 3I Atlas races toward its October 29th perihelion, the stakes are higher than ever. Some predict it will fragment under the sun's heat, shattering into pieces we can study up close. Others think it will collapse, its strange structure unable to withstand solar pressure. But a few dare to imagine something else, that this is the beginning of a new phase.